Assalamu alaikum. In this video I'm going to talk about Astable Multivibrator using 555 IC. So what is Astable Multivibrator? Astable Multivibrator is a relaxation oscillator, I mean free running. It is a square wave output signal. This is a diagram for Astable Multivibrator. So now let's understand the diagram. We already know that pin number 3 is output pin and pin 4 is reset. It is active low. So if we want to reset the IC, then we have to put here ground. As we don't need to reset, to avoid false triggering, we have to connect pin number 4 with VCC, and pin number 8 is VCC. Pin number 8 and 4 both together are getting VCC, and we have used here 2 resistor and 1 polar capacitor. Using these 3 components we can vary our output. And here pin number 5 is control volt. As we don't need any use of this pin, so we will use a decoupling capacitor here to cancel all noises through this pin. As I told you in my first video that in 555 timer IC we will get 1 output pin and 3 input pins out of total 8 pins. These 3 pins are using as input pins. This part is internal architecture of the IC, and this part is external diagram for the Astable Multivibrator. So listen carefully. Here in internal architecture there has been used 2 comparators and 1 flip-flop, and as you can see in the picture, comparator 1 is non-inverting comparator and comparator 2 is inverting comparator. So comparator 1's non-inverting pin is connect with the 2/3 of VCC, and comparator 2's non-inverting pin is connect with 1/3 of VCC. From both comparators this flip-flop will get input. See here carefully, pin number 6 threshold pin, which is connect with comparator 1's non-inverting pin, and pin number 2 the trigger pin, that is connect with comparator 2's inverting pin. Now let's say initially we are getting output high from this IC. So what is happening that time? So we have given here VCC and this is the ground, and initially Q bar's output is 1. So through RA and RB resistor the capacitor C is being charged, and same time from here threshold pin is giving positive volt in comparator 1. In comparator 1's non-inverting pin, voltage VC, voltage of capacitor will greater than 2/3 VCC, that time this converter will active and Q bar will low and Q will high. So what will happen when the Q bar will low and Q is high? The output will low, and through the Q this transistor will active, this NPN transistor will active, and it will pass negative volt from here, and it will discharge the capacitor gradually. It will depend upon this resistor's value, and same time as this is non-inverting comparator, as this is inverting comparator, so now it is getting positive volt in inverting pin. When this capacitor will fully discharged, then it will get negative volt here, and when the value, I mean volt of capacitor, will bigger than 1/3 of VCC, then this converter will active and flip-flop will change its output again. So now the output, the Q bar will active, it will high and Q will low. So as the Q is low, so the transistor will deactive, and over here the capacitor will being charged again. It will charge until this condition is true, and when this condition will true, then the capacitor will discharge again, and when this condition will true, we will get changes in output. The way this will work over and over again. We change the value of resistors and capacitor. The pulse impulse time will also vary with the variation of these three components value. Let's learn some important formulas regarding the Astable multivibrator. So for frequency, 1.44 by RA plus 2 RB multiplied by C TC. This is charging time. This is the formula, and discharging time, this is the formula. Very easy. And for duty cycle, this is charging time, this is total time into 100. One thing I have forgot. So for total time, the formula is TC charging time and TC plus TD discharging time. This is the formula of total time. Let's see what is saying in simulation. You see, we are getting square wave in out. Carry the outputs duty cycle, we have to change the value of these three components, that is RA, RB and C. So now I'm going to change the C's value. I'll decrease it. Let's say it is 50. You see how fast it is blinking. So this is how we can change the duty cycle of output by varying these three components value. Now let's see in hardware. As input volt, I have given here 12 volts, and this is a 1000 microfarad capacitor, and I have used a trim pot here. Now I'm going to change the value of capacitor. This is only 100 microfarad capacitor. Now I'm replacing this capacitor with it. So this was the negative, and you see now it's blinking fast, as I have used here low valued capacitor. So this was the hardware as in simulation. I hope you like my video. Take care everybody. Allah Hafiz.